So, good evening, everyone. We'll start with this particular thing. That is nothing but what do you mean by physics? Physics is nothing but a subject which deals with natural phenomena. What do you mean by natural phenomena? Sunrise is a natural phenomenon, right? Sunrise, morning 6 o'clock, some people are switching on. Then sun is coming. No. Evening 6 o'clock, switch off. Sun is going. No. It's a natural phenomena. Nobody can control that. It's going on, right? Rainy season, rain is a natural phenomenon. Nobody is able to control it. Similarly, this is a subject which deals with such natural phenomena. What do you mean by science? Anyone? Science means to know. Understood? To investigate or to know. You want to know something. That's why you guys are studying science. So this year, you guys are going to start learning of science. So I just want to tell you, children, please learn for knowledge, not for marks. Understood? Learn for knowledge. Learn physics, chemistry for knowledge, not for marks. Understood? Anywhere, if you guys are getting any doubts, be free to ask. Clear it. Fine. Yes. So we'll start with our first topic, that is nothing but force. Right. Force. What do you mean by force? What do you mean by force? Any idea about force? Anything? Hmm. Yes. Force is nothing but an external force which makes a body to move, or if a body is moving, it will be converted to rest. Understood. So first, let me talk about effects of force. Right. Effects of force. Children, listen carefully. Listen carefully. Children, now we are going to talk about what are the effects of force. Children, I told you force is nothing but an external cause. Am I right? Force is nothing but an external cause. What are the effects of force which we are going to discuss? The first effect is nothing but it can change the shape of the body. Children, how it is possible? It can change the shape of the body. How it is possible? Children, listen carefully. This is nothing but a body. Am I right? This is nothing but a particular body. If I apply force like this, what happened? It shape change, right? If I apply force like this, it shape change, right? When I applied force in this two corner, it shape change. When I apply force in this two corner also, it shape change. So this is the first effect of force. Understood? What is the first effect of force? Force can change the shape of the body. Understood? Any doubts? Is it okay? Fine. Now, second one, force can change the dimension of the body. What do you mean by force can change the dimension of body? Children, you can consider rubber band. You guys seen rubber band, right? Earlier, the rubber band was like this only. After some time, I'm just elongating it. What happened? It is stretching. So, the dimension change, right? Am I right? Yes. So, listen carefully, children. Force is nothing but an external cause which can change the shape of the body. You have seen that. It can change the dimension of the body. For example, you can take a rubber band. Third one is nothing but force can change the position of the object. How it is possible, children? Children, this body you consider. This body you consider. Now I am applying some force like this. What happened? It is moving. Now this body is moving like this. I'm giving a force. What happened? It stops motion. Understood? So from all this we understood what are the effects of force. I hope, children, the concept is perfect. Effects of force is nothing but force is an external cause which can change the shape of the body. It can change the dimension of the body. Third one, it can change the position of the body. That means one body is at rest. If we apply force, that body is ready to move. One moving body, if we apply force opposite, it will stop. Understood? Any doubts? Now, again, if you want to know the application of effects of force, changing the shape and all, you guys seen some friends and all. If you give nicely to here, what happened? Shape will change, right? That is your practical experience. You guys got that? No. Okay, children. So if you want to test that also, it's possible. Whether you guys have sister, brother in your home, they may be changed your shape, right? So that experience you can remember and write this particular concept. Understood? Fine. Listen carefully, children. Now we are going to talk about magnitude of force. Force, what is this equation? F is equal to mass into acceleration, right? Children, first we'll talk about what is the unit of force in SI system. So what is the SI unit of force? Children, if you want to know SI unit, first you need to take mass. What is the SI unit of mass? Kilogram. What is the SI unit of acceleration? Meter per second square. So what is the SI unit of force? SI unit of force is nothing but SI unit of force is nothing but kg meter per second square. Understood? Now we'll talk about CGS unit. Yes. In CGS unit, mass is nothing but in grams, right? What is the CGS unit of acceleration? Centimeter per second square. Am I right? Am I right? Yes. Now, what is the unit? CGS unit of force. CGS unit of force is nothing but gram centimeter per second square. Understood? Now listen, children. This kilogram meter per second square. This one we call it as Newton. This one we'll call it as Newton. Whenever you guys are writing a scientist name as a unit, it should be in small letters. Remember that whenever you guys are writing a scientist name as a unit, the complete word should be in small letter, but a denomination, the letter which you're going to denote that particular term is nothing but should be in capital letter. Understood? Ampere, small letter we write ampere, right? But it denote it as capital A. Like that you can remember. So kilogram meter per second square, we call it as Newton. Then what will be this gram centimeter per second square? This one we call it as time. Understood, everyone? Once again, I'll repeat. Listen carefully. We are going to talk about magnitude of force. When I talk about the magnitude of force, we know only one equation. That particular equation is nothing but F is equal to mass into acceleration based on Newton's second law. F is equal to mass into acceleration. Now I want to know the SI unit of force. The SI unit of force, if I want to find, don't by heart this. If I want to find the SI unit of force, I'm taking that equation F is equal to ma. What is the SI unit of mass? Kilogram. What is the SI unit of acceleration? Meter per second square. So what is the SI unit of force? Kilogram meter per second square. Understood? Now we need to talk about the CGS unit of force. For that also we are talking about the particle equation, that is nothing but F is equal to ma. What is the CGS unit of mass? Gram. What is the CGS unit of acceleration? Centimeter per second square. So the unit of force, CGS unit of force will be gram centimeter per second square. Understood? We got this two terms. Finally, we understood kilogram meter per second square is nothing but Newton. We denote it as capital N. Gram centimeter per second square, which we denote it as dyne. Understood? Any doubts? Yes. Now, children, I'm giving a one note, one small note I'm giving. Just remember this note. This is nothing but 1 Newton is equal to 10 to power 5 dyne. Understood? 1 Newton is equal to 10 to the power 5 dyne. This one is known as relation between SI and CGS unit of force. So what is the relation between SI and CGS unit of force? 1 Newton is equal to 10 to the power 5 dyne. Understood, everyone? How it is coming 10 to the power 5 dyne, I'll be explaining in second chapter, work power energy. Understood? There already we need to do that derivation. So I'll just express that. Understood? Next one, we'll talk about gravitational unit of force. Gravitational unit of force. Children, we know which are the gravitational units of force. Which are they? The first one is nothing but one movie name. What is that? KGF, right? Kilogram force. Kilogram force. That we call it as KGF. Don't write Kolar gold factor and all. Okay. It is kilogram force. Next one is nothing but gram force. That we call it as GF. What is GF? Don't write girlfriend. Understood? GF is nothing but gram force. KGF is nothing but kilogram force. Your age is the problem. That's why. When we ask any question related to KGF, you guys will go to the Rocky Boy story. That's the problem. When we ask about GF, you guys will go to the girl. So what are the different types of gravitational unit of force? The first one is kilogram force and the second one is gram force. Understood? Any doubts? Children, here I want to give one small relation. That is one note. Right. 1 kgf, 1 kilogram force is equal to 9.8 Newton. And 1 GF is equal to 980 dyne. Understood? This thing my 9th standard students will remember. Am I right? For 10th standard students, I'll tell you. Children, 1 kilo. 1 kgf is equal to 9.8 Newton. How to remember that, I'll tell you. Children, listen carefully. Listen. Kilo. 1 kilo means 1000. So 1 kgf is nothing but 1000 GF. You consider 1000 girlfriend. Understood? GF is nothing, girlfriend you consider. So 1 kgf is nothing but 1000 girlfriend is equal to 9.8 Newton. Remember, Newton have 1000 girlfriend. 1 kgf is 1000, right? So N is nothing but Newton. So remember like that, Newton have 1000 girlfriend. Am I right? If you have one girlfriend, that value will be more to that girlfriend, right? If you have 1000 girlfriend, value will be very less. So here comparing with the two particular relation, which one will have less value? 1 kgf, right? Because that value is less. Other one is 980. This one is nothing but 9.8. So the value will be less. You can remember like this. 1 kgf is equal to 9.8 Newton. How we can remember that? Newton have 1000 girlfriend. If you have one girlfriend, we can give more value. 1000 girlfriend, how will manage? Difficult, right? So that value to that girlfriend will be less. So it will value is 9.8. Lesser value you should remember. Understood? Like that, you can remember that. Next one, 1 GF. Understood? Only one girlfriend. One boy is having only one girlfriend. Then that value will be more. So the value is nothing very high, right? How much it is? 980. Finally, he will die. Die, you can remember like that. Understood? Finally, he will die. Okay. Don't say that Juicer is talking discrimination and in class and all. This is nothing but to remember physics I'm giving. Understood? Remember like this. 1 kgf is equal to 9.8 Newton. Because 1 kgf is nothing but 1000 Newton. Newton have 1000 girlfriend. Hence, its value is nothing but very less. Hence, 9.8 only the value. Then another boy you consider in the second relation. Only one girlfriend is having. Then its value will be very high. So 980. Finally, he will die. Understood? Understood. This is a warning to all the boys also. Okay. Yes. Next one. Next one. Children, you guys study 1 kgf, 1 gf, everything. Really, you guys know what you mean by 1 kgf? Anybody? Yes. Yes. What do you mean by 1 kgf? According to my terms, I'll explain. Many students are not knowing this. This is nothing but your surface of Earth. This is nothing but surface of Earth. Understood? Now here one body is the this body is mass is nothing but 1 kilogram. Understood? This body mass is nothing but 1 kilogram. I hope you guys understood. Surface of Earth. I'll draw here. Body is here. Fine. Its mass is nothing but 1 kilogram. Okay. Surface of Earth, little bit higher. You have one body of mass 1 kilogram. Now, how much this body is attracted by Earth? That we call it as 1 kgf. Understood? That means here the body will be attracted, right? The force of attraction. How much is the force of attraction? Or you can call that as force of gravity also. Force of gravity. That is nothing but 1 kgf. Once again, I repeat, what do you mean by 1 kgf? You consider the surface of Earth and a body is above the surface of Earth. Its mass is nothing but 1 kilogram. How much that Earth will attract? How much is the force of attraction between that body and Earth? How much is the force of gravity possessed by Earth on that particular body? Is nothing but we call it as 1 kgf. Understood? Any doubts? Now, then it is easy to find what you mean by 1 gf, right? What will be 1 gf, children? Yes, it's very easy. This is nothing but surface of Earth. This is nothing but surface of Earth. And you have a body. This is the body. Here, its mass is nothing but 1 gf. Understood? Its mass is nothing but 1 gf. Then how much is the force of attraction? How much is the force of attraction between 1 ground force body and Earth? We call it as 1 gf. I hope you guys understood. Any doubts? Is it okay? So I hope, children, you understood what are the effects of force, magnitude of force. Finally, you guys understood the relation between SI and CG's unit of force. Fourth one, gravitational unit of force, its relation. Any doubts? Any doubts? Is it okay? Now, you can write next study. Detailed study of effects of force. Children, my side reading will be different from your textbook because I'm not teaching for marks. I'm a person teaching for knowledge. But concept will be the complete textbook will be there, but I'll be following my own method. So this is easy to remember also. Detailed study of effects of force. Yes. Children, listen carefully. I just want to tell you one thing. Everyone feel that physics is also a subject like other science subject. But I'm telling you, this is not very easy. How much value giving to maths? The same manner you should give importance to physics also. Because in this subject, you have maths and science. Am I right? Theory is the problems, numericals also is the maths plus science is included in the subject. You guys will study how you guys are studying chemistry and biology. You guys feel that this is very easy. Never. You can check last year question paper. Before that, any seniors, just ask them. Physics was the tough exam which they wrote. Understood? Last few years, 10th standard board exam paper, physics is tough. Hence, I'm giving that alert to you people. This subject is very easy also, very interesting also, right? But one thing you should assure, that is nothing but maths, how much you're studying, that day itself you're practicing. Similarly, in physics, what are things I'm teaching? That day itself, go to your home, take a piece of paper, write and study. Take a piece of paper, write and study. Try to teach your mother, try to teach your father, try to teach your sister. Anything is possible. Everyone is busy means try to teach yourself. In that manner, you should learn. Otherwise, you won't get the grip on the subject. Children, I have this much years of experience in 10th standard ICSE. physics and chemistry. Hence, I'm telling more than what you guys are getting from school, I'll teach. Understood? If you want to use that, you should study according to the pattern which I do. Today, I complete some portion. Take rest, enough rest you can take. After that, take a piece of paper, spend 15 minutes, write and study this. Then you will be the topper in the subject. Understood? Yes. Next one. Detailed study of effects of force. I'm taking force only. I'm applying force on a body. I'm taking force and I'm applying force on a body. Children, listen carefully. I'm applying force on a body. There are two types of body. Understood? I have a body and I'm applying force to that. Now remember, there are two types of body. The first one is nothing but non-rigid body. The first one is non-rigid body. And the second one is nothing but, we call it as rigid body. Understood? Non-rigid body and rigid body. What do you mean by non-rigid body, children? What do you mean by non-rigid body? Just write the definition. The body in which in textbook, this definition is not there. The body in which the distance between the particles changed with an external force. With an external force. The body in which the distance between the particles changed with an external force. Yes, children, listen carefully. This is nothing but a body, right? This is nothing but a body. So I'll consider this is one point and this one is second point. Listen here. This is nothing but a body. This is nothing but one point. This point is something but point A. This is nothing but point B. This is the distance between them. Understood? Point A, point B, and what is the distance like this? Now, children, I am applying some force. What happened now? The distance change, right? That point A and B is there. This is nothing but point A. This is nothing but point B. Am I right? And this is the whole distance between point A and point B. Any doubts? Now I'm applying force in two directions. Like this, I'm applying force. Then what happened to the distance? The distance change, right? The distance change. This type of body, we call it as non-rigid body. Now you see the definition. The body in which distance between the particles changed with an external force is nothing but we call it as non-rigid body. Understood? Now, what do you mean by rigid body? What do you mean by rigid body? Right. The body in which the distance between the particles is not changed with an external force. Listen carefully, children. You can see this key, right? You can see this key. This is point A, this is point B. This is point A and this is point B. I am applying force like this. Whether its distance changed. No. Now we read the definition. The body in which distance between the particles is not changed with an external force, we call it as rigid body. I hope you guys understood what do you mean by non-rigid body, what do you mean by a rigid body. Any doubts in this? Is it okay? Now children, listen carefully. I am applying force like this to a rigid body. Listen down. First you get to be stored here. Knowledge should be here. Then in notebook. This is the best notebook. Got it? This is nothing but a rigid body. I am applying force like this, but there is no change in distance between point A and point B. Now children, the reason is nothing but I am not applying enough force. If I'm keeping this in a material or any machine, I'm just crushing it. It will bend, right? It will bend. So can I say that rigid body is an ideal condition? No body can exist as a rigid body. Is it possible, right? This is nothing but a rigid body because I applied less force only. If I keep it on a machine, if I crush like this, maximum force if I apply, the distance will change. So I can say that rigid body is an ideal case. Never a body can exist as a rigid body. Understood? Understood. Is it okay? Yes. Write that also. It is an ideal case. It is an ideal case. It is an ideal case. Yes, I'll explain that also. Listen carefully. So non-rigid body I'll consider first. Non-rigid body I'll consider like this. So in a non-rigid body, I'll take one sponge, children. This is nothing but a sponge. So in the sponge, this point is nothing but A. This point is nothing but B. The distance between the point A and B is nothing but D. So if I apply force F1 like this, if I apply force F2 like this, what happened? What happened? The sponge will get squeezed, right? Am I right? Will get squeezed. Am I right? Therefore, you can conclude if force is applied, in a non-rigid body, force applied on a, not in, okay, on a non-rigid body, then first one, change in shape. Then there will be change in shape. It's true, right? There is change in shape. Second one, change in structure. Structure will change. Am I right? You've seen that. You see, no, when I change, excuse that paper. Yes. Third one is nothing but there will be change in volume also. Understood? Understood. So children, consider a non-rigid body. Consider this particular paper. Sir is applying, this is point A, this is point B. Now I am applying force in this two direction like this. That is nothing, the paper is fused. Then what all effects are there? When I apply a force on a non-rigid body, there will be change in shape, there will be change in structure and change in volume that you seen here. Earlier it was a rectangle, right? Now it become a sphere. Am I right? So change in volume also will be possible. I hope you guys understood this. Any doubts? Is it okay? Now, instead of that, I'm taking, now here I'll take rigid body. Rigid body. Children, listen carefully, rigid body. This is nothing but, I'll consider it as a pen. One pen you consider. Now I am applying force here. Here also I'm applying force. What happened here? What happened? No change in structure. Am I right? No change in structure. But when more and more force is applied, more and more force is applied, then distance changed. Am I right? Distance changed. The examples which I explained by using key is an important thing, right? This proves that this proves that, right, there is no perfect rigid body. There is no perfect rigid body. There is no perfect rigid body in this universe. Understood? It's an ideal case. I hope my children understood this particular statement. Children, I'm not telling anything to by heart. Each and every physics which I explained, I'm giving you examples. Am I right? This is how you need to learn physics. So today, if you go to home and if you study this particular thing, you can experience that physics, that knowledge you attain. Tomorrow, if you're learning, after one sleep, you're learning this notes will be there, but you won't get the path, the knowledge which I given to you. Which one is benefit? You just see. Okay? Yes. Understood till this? Next one. Effects of force on a rigid body. Effects of force in a rigid body. Sorry, on a rigid body. On a rigid body. Children, here I'm just considering a rigid body. Understood? Children, I explain what happens when you apply force on a non-rigid body, right? When you apply force on a non-rigid body, there will be change in distance between the body, distance between the 2 points. Because of that reason, the size will be changed, shape will be changed, finally volume also will be changed. But children, I explained one more thing. What about the rigid body condition? In a rigid body, if you apply force, there is no change in distance, but that bodies are not existing. If some bodies exist, some rigid body exists, how they will act. That's what we are going to discuss here. Listen carefully. Rigid body. Children, there are two types of rigid body. First one is not pivoted. Not pivoted. Second one is nothing but pivoted. Listen carefully, children. What do you mean not pivoted? Pivoted. That is nothing but bodies which are free to move. Bodies which are free to move. Understood? Understood. Now, I'll consider this now body which are free to move. Children, you take one surface. This is nothing but a surface. Understood? Now you consider one person is standing. His name is Steve. He failed in 10th standard exam and he is standing in Sadundapalia road. Understood what to see. Because of his overconfidence only failed. Now children, that time I'm giving some force to him like this. Some force I'm applying. He is free to move now. All exams are failed. Nothing to do. So he's free to move. No worries. Right? So Steve is standing. I'm applying some force. What happened? This body, that means T will come here. Am I right? Will move here after a time T. Am I right? Through the surface. Understood? Children, Steve will be moving through a straight line. On the surface of Earth, he is moving through the straight line when I apply force in that direction. Am I right? Steve is moving along the force which I given. Understood? Which direction I applied force? The same direction Steve is moving. Am I right? Through a straight line. This type of motion, we call it as rectilinear motion. Am I right? rectilinear motion, or some people call it as translatory motion. Listen, I won't write. Listen, children, this is nothing but a surface, straight surface. This is nothing but a body. Now I am applying force in this direction. I am applying force in this direction. So which direction I applied force? The same direction the body is moving through the straight line. This is straight surface, right? That type of motion we call it as translatory motion or rectilinear motion. Understood? Any doubts? Is it okay? Yes. Now pivoted. Children, pivoted, I'll tell you. This is one body. This is my stick, okay? This is a body. Its center part is pivoted, right? This body center part is pivoted. Am I right? Like this, it is pivoted. Now, children, if I apply force in this direction, what happened to this body? Rotational motion, right? That means turning effect. This body is pivoted here. If this body is not pivoted, if I apply force in this direction, it will go somewhere like this. Am I right? Understood? It will go somewhere. When this body is pivoted means fixed at one point. Now I am applying some force in this direction. What happened? This body will rotate. That means when a body, this is a rigid body you consider, is pivoted at a point, that body will undergo turning effect or rotational motion. When the body is not pivoted, that is free to move, then what happened? That body will be moving along the direction which you applied force. Understood? Any doubts? Happy? Yes. So pivoted means what happens? It will undergo rotational motion. Tilak, understood? Rotational motion. Understood? Fine. This is the perfect definition about pivot and under. Is it okay? Are you getting this? Yes. So listen carefully, children. We are considering rigid body. I told you what happens in a non-rigid body. Now, rigid body is nothing but an ideal case. In that rigid body, I am applying some force. Then what happened? At that time, I understood if there is any rigid body exist, there will be two types of rigid body. One will be free to move, another one will be pivoted. That means fixed. When the body, rigid body, which is free to move means it will go which direction I'm applying force, the same direction the body will move like this. If I'm applying force in a pivoted body, it will undergo turning effect or rotation. Understood? The same thing I given to you people. Examples also given. No doubts, right? Is it okay? Now nest setting again, right? Nest setting. That is nothing but moment of force. Moment of force. This moment of force is also known as torque. Moment of force is also known as torque. Children, this part we'll discuss in next class. Understood? I hope you guys understood what are things I discussed in this chapter. Am I right? We discussed about first one, effects of force, then magnitude of force. Am I right? Then gravitational unit of force, then detailed study of effects of force, then effects of force in a rigid body. Now, children, from this topic, how they will ask question for a board exam. One board exam question will be understood from this much topic, how they will ask question for board exam. One question. Yes, you should write. I'll give the question. Should I write? So which question they are going to ask from this is nothing but board exam. Board exam question. Listen. First one, define rigid body. Define rigid body. This is the question they will ask. Children, before answering, do you know that? Do you know that rigid body? This is nothing but one board exam question they asked from this topic. Okay. So what is a rigid body? Answer, right? Rigid body is a body which does not deform under the application of external force. I hope you guys understood that particular sentence. Am I right? If you apply how much force also, there is no change in the distance between the 2 points, right? That type particular bodies, we call it as rigid body. That term I'm giving in this particular sentence. Is it okay? Is it okay? Yes. So this is the question they asked from this. Once only they ask, and I'm giving that. Okay. So I hope children you understood this particular topic and how they will ask questions from this topic also. So this is for today in physics. Today itself, go to your home, revise this. Tomorrow when you guys come back, I'll ask question. If you are not answering, my love and care will be there. Understood? Is it okay? Yes. So thank you, children. We'll meet for chemistry class now. Take 5 minutes break. Thank you.